This is a very brief introduction to practical mathematics. I define practical mathematics as mathematics that's useful for some very practical purpose, like flying an airplane. So I'm going to show you some of the conversion constants and formulas that you might want to refer to later in the course. There's two sources primarily. The first source is a file called Useful Formulas Part 1 for AERO 310. You can get this from Canvas, and if you open up the file, you'll see it says formulas for the first half of the course. This is for the AERO course. And there's a whole host of formulas and constants that you might find easy. You can Google a lot of this stuff and get the answers, but this file is particularly suited for what you might use in a discussion or some answer that you might have to find on a quiz or an exam. If I was to look at gravity, acceleration, 32.17 feet per second squared or 9.8 meters per second squared, that's called 1G. Temperature, and if you go through the rest of this file, you see there's the speed of sound, that's a function of temperature, density, and the units of slugs per cubic foot or kilograms per cubic meter. What's a slug anyway? Well, that turns out to be 32.17 pound masses. So 2 bowling balls is a slug, basically. So these are some of the things that are maybe hard to find. Might give you some time that you can find it very quickly here in this set of files. Towards the bottom are ones that I added, particularly from the class lectures on different topics, like Mach number, what's dynamic pressure, what are the formulas for dynamic pressure, and the coefficient of lift. So that's the first source, is this file, which you might want to keep handy, print it out, keep it if you've got it. The second source is a website, which is interesting. It's over here. It's called the Engineering Toolbox, and then it's dynamic pressure dash D. Well, I know you can see it up here at the top. And this is interesting because this takes you to dynamic pressure. It's the same formula that I used except you can actually calculate the dynamic pressure with units. So you can use metric units or SI units or imperial units. In other words, slugs again, feet per second. And if you put a density in here, let's say I know the density at sea level for our atmosphere is, I think, 0.00238 slugs per cubic foot, and then you hit calculate. And look here at the top, it gives you the dynamic pressure in pounds per square foot. It automatically calculates 1/2 rho v squared for you. So that's kind of cool. That's a nice place, again, as opposed to trying to Google everything. Here's a nice location where it's all concentrated for you. And look on the left-hand column here, the unit converter. You see that? Look, like here's centigrades to Fahrenheit on the left, and all you got to do is hit the convert button, and it converts everything. So you can see that what it's done is it's converted 0 degrees centigrade to 32 degrees Fahrenheit, 273 degrees Kelvin, or 492 degrees Rankine. And of course, those are the 4 temperature scales: centigrade, Fahrenheit, Kelvin, and Rankine. So that's kind of cool. And of course, you could change these numbers. You could put Fahrenheit in here and then convert. And now you see 0 degrees Fahrenheit is minus 17.8 degrees centigrade, etc., etc. So that's kind of cool. And look, if I scroll down on the left-hand side, you have conversions for area, volume, weight, velocity. So here's feet per second. So if I want to convert 1 feet per second, let's say I know. Let me just put down. Let's put down 88 feet per second because I know that's 60. That's about 60 miles an hour. So if I hit the convert button, you can see 88 feet per second, and here it is in meters per second, kilometers per hour, and then here 60 miles per hour, and that's the conversion I remember from my test pilot school days. Is 60 miles an hour is 88 feet per second. So and again, now here you see there's pressure and there's So this is a pretty useful site with the conversion factors and kind of a go-to one place. So those are the two things I wanted to present to you that might be useful in the first half of the course or on your final exam. Is because this will be open book. Will be this website or the the uh, the file, and the file is called Useful Formulas Part 1. And good luck with that. Good luck.